Hello world, welcome to CyberCrete, and today in this video we are going to see how a artificial neural network works, and we are going to compare this with our biological neuron. So let's just start. As you can see here, we have the two images. One is of our biological neuron and one is of our artificial neuron. The whole concept of artificial neural network is just inspired by how the things work inside our brain, like how the neurons are connected inside our brain. And this artificial neural network is just a way that we are trying to replicate our mind. But as you know, it is not possible till now. And if it was possible, maybe we would have something like Ultron or things like that. But hopefully it is not possible till now. So here in this picture of biological neuron, you can see that like there are many signals coming towards the nucleus, and this nucleus is performing some of the calculations, and once this calculations is done, it is just sending the signal forward. It is the same way like our artificial neural network works. Here this is our xi, these are all our inputs, which just replicates to all these types of input that is all coming from all these sites to our nucleus. And these are the weights. These weights are basically a mean to represent the thickness. Like here we can see this is more thick, this is small in size, this is thinner, and this weights basically represent how many information, how valuable is that this dendrite is to our nucleus. The more valuable it is, the more thicker it is, and the more thicker it is, the more weight it is given. And this is just basically a most simple representation of our human brain. It is not something very complex. It is the most simplest representation that we can come off. And this artificial neural network is also the most simplest form of the neural network that exists now. In this neural network, as you can see, that we have the data points, and these data points, all data points are going with its respective weight. And once it comes to our nucleus, or you can say that this is our function f, in the case of mathematical representation, means it is just basically going to be something like f of w1 x1 plus w2 x2 and things like that, and it is all going to be summed up before it is being passed to our function f. Just in the same way like this, all neurons are just coming, this is just our data point, it's multiplied by weight. And here also we can see that different types of data points are coming from the different direction, and every of them carries some weight. Like some of these dendrites are more thicker and some of them are just thinner, and the thinner means they have the less value and less significance to our nucleus, and the thicker means that it have more value to our nucleus, and so it is thicker. And that is the thing that we are basically representing here with the helps of the weight. The more thicker it is, the more weight it have, the more thinner it is, the less weight we have. And here this is just the form of the simple neural network, but this is not something that we used in deep learning. So in deep learning we have the concept of these multi-layer perceptrons. So here is an example of multi-layer perceptron. So here the first thing, like this inputs, this is basically called input layer. This is our input layer, means from here we are basically going to pass our data points that we have inside our data set, and then it is just followed by some hidden layers. And the work of this hidden layer is just to perform some type of mathematical calculation, and this hidden layer basically contains of a function f, which is basically known as activation function. And this function basically contains some activation functions, like we have ReLU, sigmoid, 10H, and many different types of activation functions that we are going to take a look in the future videos. But for now you can just imagine it have some kind of function, and once this weights and these data points are passed through this function, these hidden layers do some processing and it just passes its information to the next layer. And you can see here like this is connected to this, this is connected to this, and this is also connected to this, means everything is connected to everything. So in this case we call it as fully connected multi-layer perceptrons. Means we call it fully connected multi-layer perceptron because in this case we can see that this first input is connected to all our hidden layers, and the second one is also connected to all our hidden layers, and this process continues on. And this is basically our last output layer. Here we have two. This basically represent that we are going to classify it's like we can say it is dog, it is cat, or things like that. And if we are working, this is basically the multi-class setting. So it is basically multi-class settings, but in the case of our regression problem, it will be just a single neuron, and every data points after passing through it, it is basically going to input our result. If I have to show you in this diagram, I can show you like this. If it is not the output layer, if it was a regression problem where we have to just provide the value like 1, 2, 3, and it is just continuous in number, so for that we can basically create a single neuron, and this neuron is basically going to produce our output. So in the case of regression, we have the single neuron as the output layer, and in the case of multi-class classification, we have multiple of these neurons as our output layer, and in the case of just a simple classification problem like yes or no, we have just this simple one neuron at the output layer, which is basically going to say like its values, which is basically going to say yes or no. So this is how the basic representation of our multi-neural networks work. One very important thing of this multi-layer perceptron is how we are going to just represent it in a mathematical formula. So to represent it in a mathematical form, we write O, this is basically our output layer, is equal to just some function, this is basically the activation function, and then we have our this auto sum. That means we are basically going to sum up from I1 to n, and then we are basically going to multiply our weight. Here we can see that we have our weight, and we are just multiplying with our corresponding data points, which is basically xi. So wi is just multiplied by xi, and this is basically the mathematical form of our multi-layer perceptron, or single perceptron, you can also say that. This is our output layer. This is our output layer, this is our activation function. This is basically our weights and our data points. So this is how you can simply represent our neural networks with the help of the mathematical formula, and it is very important to know that, because if you are basically going to connect these dots of how this graphically, like how this type of neural networks is going to work in a mathematical form like this, then it is basically going to be very easy to understand how this deep learning is going to work. So I encourage you to just try to think all of these diagrams in the form of mathematical formula, so that when we are basically going to work with this mathematical formula, we can basically just think of it as the picture too. So vice versa, both are possible. But there is something very special that I wanted to show you in this video. Here you can go to the website of this playground.tensorflow.org, and you will encounter the page something like this. And this website is basically going to show you the visual representation of how this multi-layer perceptron works. So here we can see that we have the multi-class setting here, like this data points and this data points, and you can see the shape of it. The shape of it is not easy to classify, it's very complex in shape. But with the help of deep learning, we can basically easily classify these. So here we can see that x1 and x2 are basically the data points, and this is basically the feature engineering hack that we are going to apply. And here is the learning rate activation function. As you can see here, this is basically our activation function that is basically shown in this website. And this is the regularizer. Well, we are going to have a look at the regularization in more depth in the next video, but you can just think of it as this regularization is basically a mean to just add some biases to our data set so that our model does not overfit. And the next we have the regularization rate, and here it's classification or regression problems, things like that. And we are basically going to stick to classification for now. So as soon as you click on this play button, here you can see that the training of these data sets are being started. As you can see here, some of these lines are very thin, and here you can say that this line is becoming thicker and thicker, means the impact of these neurons are too higher than these neurons, because the weights of these neurons are carried, you can see here. This is the most effective neuron or the data point in our data set that is basically going to classify our entire data set. This is basically the similar representation in our brain neurons. The thicker the neuron, this just mean that the weight of these neurons are higher, than the weight of those other neurons. So means if the weight of W4 is high, means these W4 have more impact, like this data point and this weight have the more impact than any of these three data points. So that is what it basically mean. So you can just go to this website and you can have the look. You can just change the different types of data sets are available here. You can just increase the learning rate, you can play with the number of epochs, and you get to see the visual representation of how the neurons actually work. So this was it for this video, and I think that you'll have learned something new from this video. And so thanks for watching.